Lesson 10-9. Our objective is to learn to find the surface areas of prisms, pyramids, and cylinders. And surface area, here we have a three-dimensional figure. And the surface area, if we look at this side, here is this rectangle, and we can find the area, the space that takes up just this one flat side. On a three-dimensional object, we have many sides. And the surface area is the area of all the sides put together or summed. So it would be the area of this side, this side, this side, this side, this side, and this side. So in this case, where there's a rectangular prism, that would be 6 sides, and the area of all of them put together would be the surface area of this figure. Now, one of the things that you can use that's very helpful when looking at surface area is called a net. So if we have this figure here, and I were to, I'm going to take a look, this is the same figure. So here we have this rectangular prism. If I were to open it up, I end up with this shape right here. So you can kind of see, and maybe it's a little easier on this side to see, you can see where the folds of this is. So if I were to refold this back up, I can recreate my rectangular prism. Bring up the sides, and I'm back to my rectangular prism. Open it up, unfold it, and this is my net. This is what is referred to by a net. So how can we use this net to figure out surface area? Well, let's take a look at a different figure here. Here is a three-dimensional drawing of a rectangular prism. And if I were in my mind to open this up, it would unfold to look like this. This would be the net for this particular figure right here. And we see that we have some dimensions on this three-dimensional figure. We have a length of 12 inches, we have a width of 5, and a height of 2. And those dimensions follow us onto our net. We still have the same length, we have the same width, and our height here translates into these distances right there. So if we want to find out the surface area is basically this entire area that the net takes up. And we can look at this in different pieces. We have a bunch of different rectangles here. So I'm going to label these A, B, C, D, E, and F. So we have 6 different rectangles that we can look at here. And we can find the area of each of these rectangles. And we know that area of a rectangle is equal to length times width. So let's go through and just find out what these come up with. So the area of rectangle A would be area equals the length, which is 12, and the width, which is 2. So times 2, and that is 24 square inches. Let's take a look at B. So B, area equals the length times width. Well, our length is still 12. But in this case, our width is this distance here, and that distance is 5. And 12 times 5 is 60. C, area equals length times width. And this looks familiar. This looks a lot like this one up here, but let's work it out again. We have a length of 12, and we have a width of 2, this same distance right here. And again, that's 24 square inches. So D, let's take a look at D. Also looks very similar, looks very much like B. In fact, they are identical rectangles. So this distance along here, this length, again would be 12. And this distance here would be the same as the distance for B, which was 5. And that's 60. We have 2 more. We have E and F. Let's take a look at E. So E, in this case, we have a length of this direction right here, and this is 2. Just like this one up here is 2, so is this one. So we have 2, and we have a width of 5. This distance right here is also the same as right there. So 2 times 5 is 10. And for F, same thing. These are matching up again. And we have length of 2, width of 5, and 2 times 5 is 10. Now, so here we have the surface area for each one of these rectangles. Well, I want to find it for the entire figure. So I'm going to add all of this up. So 60 plus 60 is 120, 130, 140, 164, 188. And that was inches. And since it's area, they're square inches. So we can say the surface area, which is oftentimes shown designated with a large S, capital S. Our surface area for this figure is 188 square inches. Example here we have another rectangular prism. And another way of doing this, we looked at a net already, but we can just look at this three-dimensional figure and think, well, how many sides does it have? Well, it has a top, and it has the bottom, and it has a side here, and it has a side over here, and it has a front, and then it also has a back panel too. It also has a back side, back face. So we have a front and a back, a top and a bottom, a side and a side. So how can we look at that? Well, we could look at just one of these. Now, the sides are, because this is a prism, they're congruent. They're the same. And since it's a rectangular prism, this side is the same as this side. The top has the same area shape as the bottom, and the front is the same as the back. So if we know it for one of those, we can know it for both of those. So let's start with the front. And we can find the area of that front panel. And this front face is 9, a length of 9, multiplied by a width, a width of 7. So length times width of this front face. And that is 63. Well, we know that we have not just a front, but also a back. And since those are the same, we can say that 63 times 2 gives us, which is 126. This gives us both the front and the back. The area of both the front and the back is 126 square centimeters. Then let's look at the top. The top up here. So the top, we have a width here, or length, which is 9, and a length, which goes this way, or excuse me, a width, and you can think of it in either order. Since you're multiplying, it's going to be the same. A width of 5. And 9 times 5 is 45. And that's for the top. But again, since we know that there's a top and a bottom and they're identical, we can say that 45, and we can double that to 90, and that gives us both the top and the bottom. Finally, we can look at one side, and let's look at this side over here, where we have 5 is the length, and our width is this distance here, and that would be the same as this distance here, which is 7. And 5 times 7 is 35. And since we don't have one side, we have two sides, and they are identical. We can say that doubling that, 35 times 2, which gets us 70, is both of the sides. Now again, we want to find the total surface area, so we want to add all of these up, all of these areas for the front, back, top, bottom, and both sides, and that will come up with our total surface area, designated by capital S. Well, 126 plus 90 and plus 70 would come out, it comes out to be 286 square centimeters. Again, square because we were looking at area.